Ever thought your computer could be a witness? I mean, a real witness in a crime? Today, we're diving deep into the fascinating world of Macintosh forensic analysis. This is where every single click, every file, and every preference can become a critical clue in a high-stakes investigation.
Yeah, it's a crazy thought, right? But when a crime goes down, a Mac can be the star witness in the room. The only catch is, you gotta know how to speak its language.
You see, a Mac isn't like a physical crime scene. It has its own unique rules, its own hidden compartments, and a language all its own. For an examiner, the job is to decode this digital maze, one piece at a time. So let's get into the very first step every digital detective has to take.
All right, so we're at the digital crime scene. The first challenge, especially for investigators who are used to Windows systems, is just how different a Mac is. These initial steps are absolutely critical. It's all about securing the evidence without leaving your own digital fingerprints all over it.
Okay, so you can't just power on the suspect's Mac and start poking around. Nope, that's the cardinal sin of digital forensics. The #1 rule is to preserve the evidence. That means you have to create a perfect, bit-for-bit copy of the entire storage drive. We call this an image. This image becomes your new crime scene while the original evidence stays pristine and completely untouched.
So how do you do that safely? Well, the golden rule is you always use what's called write protection. This is a little piece of hardware, a write blocker, that acts like a one-way street for data. It lets you copy information from the suspect's drive, but it physically prevents anything from being written back to it. Now, Macs have this handy-sounding target disk mode, which basically turns the computer into an external hard drive. But it's a trap. A simple firmware password can block it entirely, and this is the big one. It does not replace a hardware write blocker. One wrong move here, and you could alter or destroy crucial evidence forever.
Okay, so we've got our perfect, secure copy of the data. Now the real detective work begins. We have to understand the blueprint of this digital world, the file system. This is that invisible architecture that decides where every single piece of data lives.
You know, every single file on a Mac tells a story, and the timestamps, those are the chapters. As you can see, it's so much more than just when a file was created. Investigators can see when its contents were last changed, when it was moved, or even just renamed. And, get this, even the last time it was simply opened or viewed. This detailed timeline is absolutely key to reconstructing what a suspect was doing step by step.
And check this out. This is so important. What you're looking at are two different forensic tools examining the exact same piece of evidence. On the left is a tool called InCase, on the right, one called FTK. See all those extra columns on the right? FTK is showing critical information like user IDs and permissions that are totally hidden in the other tool. The software you use can literally be the difference between a dead end and a breakthrough. Now for a really unique Mac feature that can be a goldmine for investigators, resource forks. Think of it like a secret pocket sewn into every single file. The data fork has the content you actually see, like the text in a document. But the resource fork can hide all sorts of extra stuff, metadata, icons, even snippets of text. Most users have no idea it even exists, which makes it a perfect digital hiding spot.
Here's a huge difference between Macs and a lot of other systems. When you delete a file on a Mac, the system's master record of that file often gets wiped out almost instantly. That makes trying to recover deleted files, especially their original names and locations, incredibly difficult, sometimes impossible. For an investigator, it means the digital ghosts of deleted files rarely stick around, so they have to look for other clues.
Okay, so we understand the lay of the land, the file system. Now it's time to follow the trail left by the user. We're moving on to their digital footprints. This is how we connect the dots and figure out who did what and when.
If there's one thing you need to remember about Mac forensics, it's this: property lists, or PLISTs for short. These files are the digital diaries of a Mac. They record user preferences, application settings, and most importantly, a detailed log of recent activity. They are an absolute goldmine of evidence.
And here's a perfect example of why they're so powerful. This is a PLIST file for the Safari web browser. If you look closely at that highlighted section, you can see the exact version number, 3.0.4. Now that might seem like a tiny, boring detail, but to an investigator, that's huge. It can reveal potential security flaws or tell them exactly what features that user had access to.
So using these PLIST files and other system data, investigators can build a really detailed profile of every single user on that machine. They start by finding the user database. Then they pull out key info, like the person's user ID or UID, and that UID becomes the magic key they can use to link every file and every action back to a specific person's account.
Want to see what that looks like under the hood? This is the raw data from an older Mac's user database. You can see it all right there, the user's name, their home folder, and their unique user ID, in this case 501. That number is like the digital DNA that ties this specific person to all of their actions on that computer. Think about it this way. Every app on a Mac, whether it's the web browser or the email client, isn't just a tool. It's a silent witness. Each one is meticulously recording user activity, giving investigators an incredibly detailed account of a person's digital life.
Let's just focus on Safari. This table shows you exactly where it stores user data across different versions of the operating system. As you can see, stuff like bookmarks and browsing history are consistently found in those plist files. But notice how the location for website icons changes over time. For an investigator, knowing these little details is absolutely essential.
And here it is, the smoking gun. This is a real snippet from a Safari history playlist. It doesn't just show that someone visited a website. It records the full URL, the title of the web page, the precise time of the last visit, and even keeps a count of how many times they went there. It is a perfect, undeniable digital log of their online activity.
Of course, as Mac OS X evolved, so did the way it stored data. A lot of applications, including Safari, started shifting away from plist files and began using SQLite databases instead. For investigators, these databases are just the new evidence lockers, each one a self-contained treasure trove of user activity, just waiting to be unlocked. So what's the point of all this technical jargon? It's simple. These are the techniques that solve real-world cases. This is where digital forensics hits the pavement, turning all those ones and zeros into actual courtroom evidence. Let me give you an example. Say you have a case of intellectual property theft. A suspect swears he never touched the sensitive files on the company's server, but his Mac tells a different story. Investigators check his plist files, and what do they find? A list of his recently opened documents, complete with the full server path to the very files he denied accessing. Case closed. Or how about this one? Two colleagues were suspected of having an affair. They were smart enough to avoid using company email. Instead, they used a web-based calendar to coordinate their meetings. Their big mistake? They had no idea that Safari had cached a complete copy of that calendar on both of their work computers. It created a perfect, undeniable record of all their secret plans.
We've peeled back the layers of Macintosh forensics today, and we've seen how every click, every search, and every single file leaves a trace. Plist files, timestamps, browser caches, they all weave together a really detailed story of our digital lives. So I'll just leave you with this one question to think about. What story is your computer telling about you?